Hey coding buds, so basically today's LeetCode problem 48, which is rotate image, and it is a medium level problem. And as the problem statement is KNS, you are given an cross n two-dimensional matrix representing an image rotated by image by 90 degrees, which is clockwise. You have to rotate the image in place, which means you have to modify the input two-dimensional matrix directly. Do not allocate another two-dimensional matrix and do the rotation. Okay, so basically here in the game problem, here we have an image that contains a two-dimensional matrix, and here we have to simply rotate all its value by 90 degree. That means, as we can see here in the example one here we have like 1, 2, 3, 4, 5, 6, 7, 8, 9, and we know very well if we are like rotating this thing, then this 1, 2, 3 is like comes at the last column, and this 4, 5, 6 in the middle column, and then 7, 8 is in the first column after rotating its 90 degree. Okay, similarly if I'm talking about the second example here, so if I'm rotating by 90 degrees, so this first row will become the last column, the second row will become the last second column, the third row become the last third column, and the fourth row becomes here the first column. Okay, so here these are the constraints, like matrix dot length should be like equal to n, and the matrix and equal to matrix of I dot length, and n should be like greater than equal to 1 and less than equal to 20. And yeah, that's all about this problem. So let's try to solve this problem. See, for some minutes if we think about how we can solve this problem here. So here we actually perform two things. First of all, we have to rotate it by 90 degree, and then after that we are actually getting all the value which we want. So after rotating and getting the value, how we can get the value. So as I already explained here, like while rotating 90 degree, this my first row will become it's the last column here, right? And the second row will become the second last column of the rotated 90 degree matrix, and the third row from the original image will become the first column of the rotated matrix. So by looking at this, we can say that here our rows are like converting into columns. Okay, and also it is putting at the last, like our first row become the last column, our second row will become the last second column. So here we actually perform these things. So here we compute the given image easily by 90 degree just by performing two things, which we can say as just by performing two things, which we can select transpose and reverse by using these two. That means transpose and reverse. We know very well transpose matrix. That means changing of rows into a column or changing of columns into rows are called as transpose matrix, and we know very well how we have to transpose it. So for that, as our function is of void type, so it will not return anything. We have to just change it the original matrix. Okay, so and here it is already mentioned that we don't have to create any other two-dimensional matrix and perform rotation. Okay, we don't have to do like that. Okay, so here we can just simply do it within the same void rotate function. So here first of all we have to traverse inside our original matrix, which is like 1, 2, 3, 4, 5, 6, 7, 10, and we know very well how we have to traverse inside the two-dimensional matrix. So for that, for int I is equal to 0, I is like less than, first of all we have to define the size of the length of the matrix, and if we know whether it is a two-dimensional matrix and it is also a square matrix, so here we can set int n is equal to matrix dot size. Okay, once we have like done this thing, so for int I is equal to 0, I is like less than n, and then I plus plus. Okay, and then for int j is equal to I plus 1, j is like less than n, and then j plus plus. So if we are going to like return or console it here, as it is a void type, so we can't have to return it here, but if we have to return our original value. So if I'm like returning matrix of I and j, then actually I'm getting this value as it is, like in the form of 1 2 3, then 4 5 6, then 7 8 9, because we have not done anything yet. Okay, now we have to first of all transpose. Okay, so here I can also mention it. Okay, so it's my step first where I'm going to transpose the matrix. Okay, that converts our rows to column. Okay, so here we have to just simply transpose it. That means converting of rows into columns. So for that we can just simply perform swap operation. Okay, swap is an inbuilt function by which we can easily able to get our rows. By which we can just simply convert our rows to a column. So swap, what we need to swap our rows to column and column to rows. So for that here I have to just simply swap our matrix of j and I. Okay, now once we have like performed these things, and if I am like going to return here, so I am actually getting what? So if I am going to just return here, what I am actually getting, let's try to see. Okay, so swap of matrix. Okay, so here I have to write complete matrix. Okay, not just mat, because it is already, as we have used matrix inside the functions parameters, so we have to just write it complete. Again, let's try to compile and run. So yeah, after performing all those things, as it is already we know that it is a wrong answer, but I'm just showing here after transposing what we actually getting. So we is, as we can say, our first was like 1 2 3 4, and second was like 4 5 6 and 7 8 9. So after performing this, what I'm actually getting here, I'm actually getting 1 4 7. Okay, like in this way. Okay, then 2 5 8, and then 3 6 9, but in the reverse order. So as I'm actually getting the things correct. Okay, after uh, swapping or after transposing. Now what I have to do, after just this thing, I need to perform our second task, which I can say that I need to reverse. Okay, so in step 2 I'm actually getting the correct output, but in the opposite direction, like 147 to, so 258 from the backward direction, and then 369. So we can just simply reverse each row. Okay, now reverse each row to get the final 90-degree matrix output. Okay, so here we can do one thing again. For int I is equal to 0, I is like less than n, and then I plus plus, and here I have to just do one thing. That means here I need to reverse. Okay, reverse is also inbuilt function where I need to reverse only each. Okay, reverse matrix of 0. Okay, here I have to just reverse only each rows. Okay, so matrix 0 dot begin, and matrix of okay, then we have to just simply return. Okay, let's try to compile and run. Okay, so yeah, actually I've done here one. So basically it is only correct for the first index value, so we have to just do it for all. Okay, let's try to compile and run again. Now yeah, here compilation is completed, and it's execute well, and finally I'm getting our output. So let's try to submit it. So yeah, it's submitted. So yeah, that's it for today. Thanks for watching.